Okay, hi everyone. Okay, so tonight we have one class, chapter 5, waves, form 4. So tonight I will discuss on topic 5.2, 5.3, and if enough time, I will proceed to 5.4. Okay, so I will use textbook and also some extra notes for this one. Okay, let's start. Okay. Okay, maybe some of you can say hi, so that I can see those online tonight with me. Hi, Lindsay, Kathleen, Edwin. Hi. Okay, now let's go to 5.2. So before I start with damping and resonance, okay, let's recall the previous lesson on topic wave. The first part, 5.1, we have discussed on fundamental of wave, where you study about okay terms, important terms for waves, something like crest, trough, and then the in phase, wavelength, frequency, speed, period, and I hope you already memorized the definition. Okay, let's go to the basic. We have discussed what is wave, right? Okay. Normally is an energy carrier. It transfer energy without transferring matter. Okay, that one is the basic properties of wave. Is an energy carrier that transfer energy without transferring matter. When we talk about wave, how wave is produced, it produced by an oscillating system or vibrating system. What is this oscillating and vibrating system? Okay, for example, a swing or a pendulum, then this one. Okay, once you displace it to one side and release, it will oscillate. Okay, let's say here is O, here is B, A, and here is B. Means let's say displace to A, then from A go to B, and then B, it's like repetitive motion, moving to and fro along the same path. So pendulum is one example of oscillating system or a loaded spring. Okay, or loaded spring. Okay, when you pull it down a little bit, displace it down, and then you release. It will also oscillate up and down, repetitive motion also. So loaded spring is also one example of vibrating system. Okay, energy of a system that oscillate. If it able to maintain the energy, it will keep oscillating without stopping. It will continuously oscillate, but that never happens. Okay, when you carry out experiment, especially the pendulum experiment, you can see you displace it one side. After a few minutes, finally, okay, it will stop. Okay, when it stop means you can say there's no more energy. It will stop already. Okay, where does the energy go? So that one we will discuss on this topic. The first topic that we want to discuss for this one is about damping. We want to discuss what is the concept of damping. Okay, an oscillation system that is displaced and left to oscillate without action of external force will oscillate at natural frequency. So you must understand this one first. for pendulum, the factor that affect frequency, length, gravitational acceleration, where F equals to 1 over T. So you have 1 over 2 pi G over L. Okay, so means the length of pendulum affects frequency, or we can say natural frequency of the pendulum. Okay, if you have question, just write in the like in the chat. Okay, Cikgu Miss Rita. Okay, write in chat if you have any question. Okay, what happens to amplitude of oscillating system after some time? Okay, let's watch this video. I have this video regarding this one. Activity to show damping. Damping. What is damping actually? Okay, let's watch the video. I hope you can see the video, right? Okay. So we have the video here. Okay, this one pack of sugar. Okay, you just poke a hole below, hang it to a string, and then you pull paper. You can try it at home. Pull this blue paper, and then you can see the pattern form on the blue paper. Okay, look at the amplitude. What I want you all to observe is that the amplitude of the shape that produced, can you see, is decreases. Okay, become shorter. Okay, become shorter. As you can see, the pendulum sugar also become a bit slower moving, and finally it will stop. The one is showing one activity of damping. Okay, damping. Okay, this one you can try. Okay, this is at least a 1 meter length thread, plastic bag filled with granulated sugar, and then this one you can put a black pepper. Okay, displace it to one side, let it to oscillate, and then at the same time you pull the black pepper. So you can observe the pattern form on the black pepper. Okay, showing that the amplitude of oscillation decreases. Okay. Is it clear, the sound? Clear tak? Because it's raining here, I takut ada Wi-Fi tu ada effect sikit. Okay, the phenomenon just now that you observe, amplitude of oscillation decreases with time. Okay, amplitude decreases with time means the pendulum experience damping. That one is phenomenon of damping actually. Okay, if you draw a graph to show the displacement against time for the oscillation just now, you will get something like this. Okay, if no damping, it should be constant amplitude. Okay, constant, same amplitude. Okay, this amplitude keep constant. Okay, or something like this. If you have amplitude against time graph, okay, so the graph should be, this is the amplitude, and then the graph decreases with time like that. Okay, this one is damping. If no damping, it should be like this. A against time, constant. This one is no damping. This one is with damping. So you can see the amplitude decreases. So if you are asked to draw displacement against time for damping, okay, you can draw the dashed line, the red color, as a control. This one showing that the amplitude decreases, same as this one. Okay, decreases amplitude. Same thing for the trough part. Okay, and then you draw a few number of waves, more than 2 waves. Okay, don't just draw one, not enough. Draw more than two. Here we can see how many we have. Crest to crest, 1, 2, 3. Here got 3 waves. Okay, and the frequency or period constant, no change. Time taken for one complete wave must be constant. No change in frequency. Only the amplitude decrease. Okay, so this one, make sure you know how to draw. Okay, section A, maybe they ask you to draw this type of graph, displacement against time for damping. Okay, so this one showing amplitude of oscillation decreases with time. Okay, amplitude decreases with time. So there are two graphs here. This is displacement against time. This is amplitude against time. So what causes energy to loss? What causes amplitude to decrease? Okay, actually amplitude represents energy of wave. If you look at the C wave, C wave, strong wave means high energy. Okay, the wave is very high and strong. Okay, low energy, the wave is quite low and a bit weak. Okay, so it means the amplitude actually represents the energy. Is related to energy. Okay, related energy. Okay, the higher the energy, the higher the amplitude, okay, of the system. Once amplitude decrease, meaning energy decrease. What causes energy to decrease? Meaning energy loss. Okay, so this phenomenon is known as damping. Oscillating system experience loss of energy due to, there are two types of damping here. One is external damping, where oscillating system loses energy to overcome friction or air resistance. Okay, so the move in air means there is air resistance. So there must be work done to overcome air resistance. So energy loss. That one we call it external damping. Okay, at the same time, oscillating system also loses energy because of stretching and compression of vibrating particle or the molecules of system. Whether molecules of the string, molecules of the bulk. Okay, they are vibrating. Okay, so this one also will cause energy to be lost. That's the reason why amplitude decrease. Okay, so when they want you to explain this phenomenon, you must state the definition of first. Means damping is an oscillation with its amplitude decreases with time. This is the definition already, definition. You die definition. Okay, and then you can describe more. If the question want you to describe damping, so you can state the definition and then you can explain these two causes of damping. External damping, internal damping. Okay, so that one is a concept of damping or phenomenon of damping. Okay, so I hope you understand this one. Okay, let's go to the notes. Okay, lihat notes sedikit. Damping. What is this damping? Okay, here already given. Okay. Reduction or decrease in amplitude due to loss of energy, frequency constant. At the same time, period also constant. Okay, cos equals 1 over t. Okay. Okay, the graph just now, displacement against time. So when you draw, you can see from here, okay, time taken for one complete oscillation must be constant. Means T1 equals to T2. Draw at least 2 waves for this graph. Okay, here is the question here. How to overcome damping? Okay, example, baby's cradle. This is a baby's cradle. You know what is baby's cradle? Yeah, spring to baby's cradle. Okay. Now, normally it's easier to find the cradle which can maintain its oscillation. It never stops. You just turn on the switch and it will continuously oscillating. Okay. Dia akan terus ayun tak stop. Okay. Sampai you off the switch. Because it's using motor. Okay. Electric motor supply energy continuously to the cradle. So no chance energy loss because there's energy always supplied. Okay, so that one is a method to overcome damping. Okay, electric motor. It suggests one method to overcome damping. Okay, for baby's cradle. Okay, how to overcome damping? Apply periodic external force on the oscillating system. What is this meaning? Let's say you play swing with your sister. Okay, you push once, then it continue oscillating. When it start to stop, nearly to stop, you push again. So your action, we call it periodic external force. The periodic external force will maintain the swing to oscillate. That one also is a method to overcome damping. Okay, periodic force means act at specific time, not continuously. Okay, so this force will transfer energy into system to replace energy loss. Okay, so this is the concept of damping. Okay, okay. Any question regarding damping? Ada soalan? Any question? Jing Yi. No question. Okay. Okay. If no question, then I proceed to the next one, resonance. Okay, resonance. What is this resonance? Okay. Just now, I already mentioned about natural frequency. Okay, frequency of the oscillating system without external force. Okay. When you observe a pendulum before you apply force, it seems like the pendulum is at rest, not moving. Does that mean its frequency zero? No, because the molecules of the system, okay, continuously vibrating, correct or not? Okay, anything that vibrate, there must be frequency. So I mean the system now, there's no external force act. Okay, so the frequency of the system now is natural frequency. Or for a simple pendulum, you just apply periodic force. Okay, you apply, you displace it to one side and then you release. Okay, the moment you apply periodic force, you pull to one side and then you release. Okay, the pendulum will receive force frequency. We call it force frequency. Okay, and when you left it to oscillate without no more force applied, that one will oscillate at natural frequency. Okay, so you must understand the force frequency is when you apply force to the system. Natural frequency when no external force act on the system. Okay, what is this the meaning of phenomenon resonance? Okay, phenomenon of resonance occur when a periodic force is applied to an oscillating system at its natural frequency, causing the system to oscillate at maximum amplitude. So this one will be the definition already. Okay, look at the situation here. Let's say natural frequency of wave is 5 hertz, or we can say something like the pendulum lah. Natural frequency 5 hertz. Let's say you apply force frequency. This is force frequency. frequency 10 hertz. From here, you compare to natural frequency. Looks like force frequency is not same as natural frequency. Tak sama. When not same, resonance does not happen. Okay. Now force frequency applied is 5 hertz. Same as the natural frequency. So when same, then resonance happens. In the case of pendulum here, if force frequency equals to natural frequency, okay, natural frequency, what happens to pendulum? It will oscillate at maximum amplitude. Okay, maximum. It will receive the highest energy. That's the meaning. Okay, maximum amplitude. Not necessary, higher force is applied. If you apply the same frequency of force, then only you get this resonance phenomenon. Okay, I want to show you some video on this. Okay, resonance. The Tacoma Bridge. So this is the Tacoma Bridge. Okay. You imagine how can this a very strong bridge suddenly oscillate, okay, at high amplitude due to, okay, a wind that blows. Suddenly it oscillates like that. Okay, I want to move forward a bit because I want to show you what exactly happened. All right, from here you can see clearly. Okay, the road of the bridge, okay, oscillate. Okay, finally it breaks. Okay, can you imagine due to no need a very strong wind just to make this suddenly cool. Means frequency of the wind that blows equals to frequency of the bridge. Thus the bridge oscillate at a very high amplitude and causes the molecules or the particle move at maximum amplitude and then split away from the bonds between molecules. Thus it breaks. Okay, so this happens. This is one example showing that resonance, the bridge experiment. Okay. Another one. This is activity that can be done in the lab using a tuning fork. Okay, I make it forward a bit. So we have two identical. This is the first one and the second one. The second one, we put one ping pong ball tied to a string. Okay. Forward a bit. Okay, we must put the tuning fork closer actually. Okay, look at carefully. Just knock the first tuning ping pong ball here at the vibrate. Okay, and causes the ball to vibrate. Okay, so we look at again, look at the ping pong ball. Okay, these two tuning fork, identical means they have same natural frequency. The same system that has same natural frequency. Okay, or we can say the force frequency received by second equals to natural frequency. Okay, resonance, or we can say it oscillates at highest amplitude. So the second tuning fork experience resonance. Okay, resonance. Okay, look at this one, button pendulum. For button pendulum, we have X, A, B, C, D, E, and F. We have X and E same length. Just now I already mentioned frequency or natural frequency of a pendulum depends on length of pendulum. Okay, this one all experience same G because all on Earth. So means frequency just depends on length of pendulum. Same length means same natural frequency. What happen is displace this X to one side and causes it to oscillate. Okay, this one oscillate first. Then what happen? Energy from X will be transferred through the wire or the string here to another pendulum. All pendulum will oscillate. Okay, all pendulum will oscillate because there's energy received. But this pendulum E will oscillate at maximum amplitude because it receives energy from the system which has same natural frequency. Okay, so the force frequency received by E is equals to natural frequency. Or we can say that E experience resonance. Okay, thus pendulum E oscillate with largest amplitude. Okay, so this is the activity that we can carry out. The name of this one is button pendulum resonance. Okay. Okay, effects of resonance in daily life, the collapse of Tacoma Narrow Bridge in Washington, unexpected oscillation of London Millennium, footbridge tuning of musical instrument. Okay, another one is to tune to radio. Radio, you want to watch the radio, for example, radio 2, okay? So you need to tune to the correct frequency, then only you can hear the, the radio 2 clearly, and loudly. Means resonance occur. Resonance. You also apply a concept of resonance, okay? Okay, let's try some question from here, okay? Okay, you all try dulu. I give you 5 minutes to try. This one from notes. If you have the answer for number 1, then you can write in chat. Anyone with answer? Alex swing himself on the swing. He notices that after some time the swing stopped. Explain why. Okay, it means this one, the amplitude becomes smaller and smaller, finally stop. Okay, so this is damping, correct or not? Damping. Yeah? So you must explain using damping. Okay. Swing. Okay. Swing. Decreases with due to energy loss. Okay, this one if the marks provided 2 marks, you can get 2 marks. Okay, if the marks provided is 4 marks, you need to elaborate more. Explain about external damping, internal damping. Okay, so this is the answer. The swing experiences damping. Amplitude of the swing decreases with time due to energy loss. Okay, number 2. Which one is the more accurate displacement time graph to represent damping? First or second one? First graph or second graph? Which one is the correct graph to represent damping? First or second? Anyone can respond? Ni ada ramai ni. Edwin? Edwin said second. Okay, Kevin, Tanjin Chia. Okay, Chang Ming Hui. Okay, first. Okay, let's look at the graph again. Okay. Okay, just now we have discussed about damping. Damping, what is changed is only amplitude. What happened to period or frequency? Okay, ini unchanged, ya, tidak berubah. Period C does not change. Okay, let's check. Amplitude, yes, both changes, both decrease, both. Okay, now check the period. Okay, this is T, this is 2T. Okay, same. So from here, period constant, frequency constant. Now check here. This is period. This be 2T? Can this be 3T? No. You can see clearly, period not constant. So this is wrong already. This is the correct graph. Okay, so make sure when you draw or you answer question, especially in paper 1, check amplitude decrease, frequency constant or period constant. Okay, so number 1 is the answer. Okay, number 1 is the answer. Okay, number 4. An opera singer is performing in front of audience. After a while, her voice causes glass to shatter. Using your knowledge of resonance, explain this phenomenon. Okay, maybe you have watched a video. A singer, when she sings, suddenly one glass breaks. Boleh tak you buat macam tu? You can try lah. Ambil satu glass and then try to produce sound until the glass break. So what caused this situation? This one is knowledge question. Kalau keluar paper tu dia adalah 4 markah. Banyak markah ni. Okay. So means you are applying concept of resonance. So here mention, you know lah resonance. Sometimes they don't mention. You must know what concept to use. Okay. Remember just now I mentioned always add in definition. Okay. Okay. The signal voice. Yes. The natural class. The class experiences resonance that cause the molecules of the class to oscillate at maximum amplitude. Thus, the glass shattered. Kalau tak nak tulis pun tak apa yang last. Okay, means we add in the concept of the resonance, which is the singer's voice frequency. This is a force frequency equals to natural frequency of the glass. She produced sound at force frequency equals to natural frequency of the glass. So what happens? The glass experiences resonance that causes the molecule of the glass to oscillate at maximum amplitude. If the amplitude is too large, suddenly the molecules also can break itself from the bond between molecule, the glass can break. Okay, so this is how we explain by using the concept of resonance. Okay. Okay, so you must know the concept in order to answer, especially knowledge question. Okay, look at number 5. Diagram shows tuning forks, same frequency. Or we can say identical. Okay, identical, sama. Ini kita panggil prongs. Okay, dia punya dua ni panggil prongs. Okay, we call it prongs. Okay, so they have same natural frequency. Okay, identical means same natural frequency. Okay, let's say just hit this one, struck this one, tuning fork A struck. Okay, when struck, it causes the prongs to vibrate. Once vibrate, it will produce sound. Sound energy will be transferred to the second tuning fork. Tuning fork B receive a sound wave, which is at the force frequency equals to natural frequency. Okay, means tuning fork B will experience resonance. So this one will cause the prongs of the tuning fork will vibrate at maximum amplitude. So tuning fork B experience resonance. Okay, this is what happened based on the diagram. Okay, let's try to answer the question below. What is the meaning of resonance? Okay, actually resonance is a phenomenon, uh, an oscillating system oscillate at maximum when force frequency is equal to natural frequency. Must be this one now. Force frequency equals to natural frequency oscillate at maximum amplitude. Itu dia punya key ya, key answer dia yang ni. Oscillate maximum amplitude force frequency equals natural frequency. Okay. Explain why tuning fork B produces sound even without being struck. Okay, B, you can write down tuning fork B experience resonance. Okay, itu saja jawapan dia. Kalau 1 mark, itu saja jawapan. Kalau 2 marks, kena explain lagi. Okay. 2 marks, kalau 2 marks, explain. Tuning fork B experiences resonance because force frequency is equal to its natural frequency. Okay, so you just when you answer, you just look at the marks provided lah. 1 mark or 2 mark. If 1 mark, just stop here. If 2 mark, just add some more. Okay, what is amplitude? Okay, what is amplitude? Okay, do we need to write a definition, or we want to write in just state the value of amplitude? Okay, make sure don't get confused this type of question. If the question want you to state what is amplitude, means value. Soalan ni macam ni. If they want you to write definition, what is the meaning of amplitude? What is meant of amplitude? Then only you write the definition for amplitude. This one just want you to determine amplitude. This is the original position, or we call it equilibrium position. Vibrate to and fro. So means amplitude is this one. Either you take this one or you take this one. This is amplitude. So from here we can see amplitude equals to 8 divided by 2. 0.4 centimeter. Okay, so you write down the answer here. What is amplitude? Okay, 0.8 divided by 2, 0.4 centimeter. Okay, and then part D, if the frequency of tuning fork is 500 hertz and speed of sound wave 330, calculate wavelength. Okay, this is frequency F. This is speed. You want to determine wavelength means lambda. Okay, you want to find lambda. Formula V equals F lambda. Okay, so lambda equals to V divided by F means 330 divided by 500. Okay. Check the unit. Sometimes frequency they give with prefix. Okay. Then you must convert to SI unit. Remove the prefix. 330 divided by 500. So you get 0.66. What is the unit? Check again. This is meter per second, hertz. Okay, so we have unit ialah meter. Okay, 0.66 meter. Okay, so that one is topic damping and resonance. Okay, do you have any question? Ada soalan? Yes, anyone? This question? Ada soalan? Just remember the definition for damping. What is damping? What is resonance? Okay. Okay, if don't have question, then I will proceed. So I will take quite longer time tonight. If you are very tired, you can stop and then you can watch later. Can, because this is a YouTube. You can repeat to watch this. Okay. Okay, I will continue. Next one is reflection. Okay, of wave. Okay. So the next topic 5.3, 5.4, 5.5, 5.6 all discuss about phenomenon of wave. Okay, there are 4 phenomena of wave: reflection, refraction, diffraction, interference. Okay, I will stop at 10. Let's try what sampai mana saya nak stop. Kita tengok saja lah. Okay, let's look at the first one, reflection. Okay, what is this reflection? The word reflect, when we talk about light wave example, when you use mirror, okay, and let the light gets into the mirror, and you point it on the wall, you can observe there is reflection of light. Same thing as when you throw a tennis ball, so the ball bounce back. Same situation as the light wave. It also bounces back. Okay, so water wave also bounces back. For example, at the sea, there's a big rock there. The wave coming towards the rock and then it bounce back or reflect. So the reflection also we can also use the word bounce back. Pantul apa tu? Bounce back. Patah balik, pantul balik lah macam tu. Bounces back. Okay, tennis ball bounces back. Okay, wave also, water wave bounces back. So that one is a reflection. So for wave, we use the word is reflection of wave. Okay, so for reflection, this is light, light reflection. Ini adalah light example. Let's say light hits a mirror. Ini adalah mirror. Okay, this is incident light or incident ray. Hits the mirror here. It reflects. Okay, at the point of incident here, we can draw normal line. Normal line is 90 degrees to the mirror. Angle between the ray and the normal line is incident angle. I ini ialah angle of incidence. It bounce back or reflected at same angle R, where angle I equals to angle R. This is law of reflection. Okay, law of reflection. So this one is light wave. The arrow is the direction. You can see this line. This line, wavefront. Wavefront is 90 degrees to direction. So this is incident light wave. This is reflected light wave. Okay, let's look at the characteristic before and after reflection. Okay, before reflection, angle is I. After reflection is R, same size. So angle, no change. No change in angle after reflection. Okay, maksudnya angle tak berubah. Let's look at the wavelength. Wavelength is distance between two wavefront. If you draw here, it's wavefront for crest, meaning crest and crest is lambda. Here also is lambda. So no change in wavelength. No change in wavelength. Okay, frequency, no change. Because frequency depends on source of wave. The wave coming from the same source, coming from a torchlight, for example, coming from the same source. So they have same frequency. So it's also we can say no change in frequency. Okay, based on the formula of V equals to F lambda, if no change in frequency, no change in wavelength means no change in speed. So speed also no change. What is change? Direction change. You can see the arrow change. So direction change. Then we can say for reflection of wave, no change in V, F, and lambda. But there is change in direction of wave. Because it bounced back, of course, direction will change. Okay? Okay, application of reflection of wave. Ultrasonic to examine fetus and internal organs, sonography or ultrasound. Okay, sound wave can be reflected, so means there are advantages of this sound wave. But for sound wave, you must understand sound wave dia ada 3 level. First level is infrasonic. Depends on its frequency. Infrasonic. Infrasonic is less than 20 hertz. Second is audible range. Audible range is between 20 to 20,000 hertz. Any audible range. Then the last one is ultrasonic. 1,000. More than 20 kilohertz, 20,000. Okay, so infrasonic, audible range, ultrasonic. This is sound. Okay, so sound wave can be reflected. Okay, when you enter a cave, for example, okay, when you produce sound, you can hear back the sound coming back to you, or we call it an echo. Reflected sound wave, we call it echo. Echo, bergema. Okay, and echo. Okay. Ultrasonic wave. Why we choose ultrasonic? Kenapa advantage untuk ultrasonic? Infrasonic, frequency low, we cannot hear the sound. Okay, maybe sound produced by talking ants. Mungkin semut tu dia bercakap, cannot hear. So maybe it's a very, very low frequency. Audible range, this is what we can hear. You can hear my voice, my voice is under this audible range. Okay, and then we have higher frequency, ultrasonic, more than 20,000 kilohertz. So this one, very high frequency sound, human cannot hear. We cannot hear this sound. Okay, this is high energy sound wave, very high energy sound wave, and very strong, very high penetrating power. That's the reason why for ultrasonic wave, it can be used to examine fetus and internal organs, sonography or ultrasound. Okay, untuk yang pregnant woman, they always go and check using ultrasound. So the sound wave can enter the skin and go to the fetus, internal organs. So when hit the internal organs and the body of the fetus, it reflects. The reflected ultrasonic wave created image that can be that you can observe on the screen. Okay, so the other receiver and transmitter. Transmit ultrasonic wave, receive ultrasonic wave. Okay, so it will create the organs and also the fetus. Okay, that's why we use ultrasonic. Dia pun tak bising lah, does not produce any noisy sound because human cannot hear. Okay, another one used to detect fish, fishermen using this ultrasonic, we call it sonic system. Sonic system also using ultrasonic. Okay, transmit ultrasound into the sea. When the ultrasonic wave hit a group of fish, okay, the ultrasonic sound reflect, received back by the receiver. The receiver will show image, means there is a group of fish at certain depth. Okay, this one is the using or application of reflection of wave. Okay, so ultrasonic wave is very widely used. Okay, another one is radio wave, communication satellite, parabolic dish, focus onto antenna on feed horn. Okay, radio wave untuk communication. Sonar, ini tadi yang saya sebut, sonar ataupun sonic system, same thing. To detect area with fish ataupun detect depth of the sea. Dalam laut, boleh gunakan sonar system ataupun ultrasound. Okay, ultrasonic wave. Okay. Sound wave, pattern of reflected sound wave due to different rocks enable to identify areas with sources of natural gas or seismic survey. Banyak kegunaan, especially sound wave. This is application of reflection of wave. Okay, let's look at the solving problem involving reflected wave. Let's say this girl produced sound, shouting, and then the sound hit the wall. Distance between the person, the girl and the wall is d. The speed of sound in air is v. Okay, the time you just can record the time, the moment release sound and receive back, because we don't know when it hit the wall. Okay, if you use stopwatch to measure, you just can record time taken for sound, move towards the wall and come back two-way, come back. So the time taken. When we use the formula of V equals to D divided by T, distance divided by time, means distance equals to VT. Okay, ini yang general formula. But for this case, the time taken that used here is time taken for one way, because distance is one way only. So that's why here the time needs to divide 2. The time needs to divide 2. Because distance one way, time taken just now is for two way. Pergi balik. That's the reason why we get this formula. So this formula can be used to determine distance between girl and the wall. You also can calculate if you have the speed of sound. Okay, uh, you want to determine your distance between the wall, and then you can record the time taken. That means there's no obstacle in between, no obstacle, just the wall. So we can calculate by using this formula. Okay. Okay, do you have any questions pada soalan tu? Okay, ada soalan tak? So itu reflection, reflection of wave, reflection of wave. So what is definition based on that? Okay, reflection of wave wave bounce back as it hit an obstacle or strike an obstacle ataupun reflector pun boleh, an obstacle. Okay. Ataupun a reflector pun boleh. Okay, reflection of wave means wave bounce back as it strike an obstacle or reflector. So for reflection, we can discuss for all type of wave. Water wave also reflect. Sound wave also reflect. Light wave also reflect. Okay, so when we discuss about sound wave, mostly we discussed just now, sound wave reflect when hit a hard surface. Let's summarize that. Okay, let's summarize that one. Okay, when we talk about water wave also bounce back. Example like strike a rock, a big rock, especially at the sea. Okay, when we talk about this one, heat reflector. Heat reflector or obstacle, penghalang, obstacle satu penghalang, macam batu besar kat tepi laut, itu adalah obstacle. So when hit an obstacle, it bounce back. When I talk about sound wave, permukaan yang keras. Okay, it bounce back like a rock. Okay, a wall, a concrete wall, hard surface. Sound wave cannot reflect if hit a soft surface, like hit a curtain or hit a cloth or a carpet. Cannot reflect sebab soft surface akan absorb sound. Okay, so hanya hard surface. Additional ialah smooth lah. Lagi bagus lah. Smooth and hard. Light wave. Hit a shiny surface. Dia dah beza kan? Macam Ira. So yang differentiate or not? Maksudnya all these three type of wave will experience reflection. All reflection. Depends on what type of surface it hit. What type of obstacle. Okay? Kalau ada soalan, just write in chat. Kalau ada soalan, I know it's quite long, long class. Jadi takut ada yang dah mengantuk dan bosan. Itu je. Because I cannot see your face now. Okay, exercise. Okay, let's look at exercise for this one. Diagram shows wave fronts of water wave propagating towards the barrier. Barrier, ada barrier kat sini. After the wave reaches the barrier, the wave will be reflected. Sketch the wavefront of the reflected wave. If the speed of incoming wave 15, calculate frequency. Okay, let's try. Okay. This one with arrow is direction. Okay, means the whole thing here. This blue line, wavefront. Ini wavefront, tahu? Saya tak perlu tulis aku. I hope you understand lah. Ini kita dah belajar kan? Okay, ini line-line perpendicular to direction semua ni. Ini panggil wavefront. Okay. So the whole thing, this one, we call it incident wave. Ini ialah incident wave yang ditujukan. Yang datang tu kita panggil incident wave. Let's just continue or extend the direction. Guna ruler, gitu kan. Okay, hit at this point. This is the barrier. This is point of incident, kita panggil. Okay, at this point, draw normal line. Use ruler, draw dash line. 90 degrees to the barrier. Angle between incident wave and the normal line is angle of incidence. Okay, this one is law of reflection. I hope you already studied in lower form about law of reflection. Okay, so based on law of reflection, the water wave will be reflected at same angle R equals to I. Okay, dia akan reflect dekat angle yang sama. Okay, continue to draw here. Ini sketch saja, sketch tak perlu accurate lah. Tak perlu pakai protractor nak measure sebab sketch ni. Okay, maksudnya macam ni lah. So ini angle R. Jadi make sure bila you draw tu tak adalah perbezaan yang besar. I equals to R. Okay, now we want to draw the wavefront. Remember, we already mentioned for reflection, V, F, lambda, no change. Ingat tu. Mana lambda? Sini lambda. Means when you draw the wavefront for this side, must be same lambda, same lambda. Okay. Draw the wavefront 90 degrees to direction. This is reflected wave. Lukis 90 degrees. Mungkin saya lukis sangat sikit. Same lambda guna ruler. I cannot use ruler here. Nampak tak sama Never mind, I try to draw again. Okay, let's try it. Much better. Just draw, add some more, maybe 4 lines. Okay, so this one is reflected wave. Lambda dia tak ada ubah, lambda sama besar. Kalau you ada ruler, you bolehlah ambil ini. Kalau ini 1 cm, maksudnya ini 1 cm. Okay, macam tu. Kalau ini ialah 7.5 cm, maksudnya lambda equals to what? Between two wavefront, lambda. Ini lambda. Ini pun lambda. So kita ada 3 lambda equals to 7.5. Di lambda ialah 2.5 cm. Okay. Kalau dia measure, dia dah bagi measurement yang macam ni, you bolehlah ikut dia. Okay. So ini lukisan untuk wavefront of reflected wave. Okay, done. Maksudnya lukisan mesti ada apa? Normal line, labelkan angle, draw direction of reflected wave, draw wavefront. Wavefront mesti 90 degrees dengan direction. Tak boleh cincai lukis. Ada dulu belajar lukis cincai saja macam ni. Tak ada salah. Tak boleh mesti 90 degrees itu memang yang betul punya, yang betul. Okay, let's try to answer the next question. If the speed of incoming wave 15, calculate the frequency. Okay, from here we have lambda already. Lambda ialah 2.5 cm. The speed given 15 centimeter second negative 1. What is frequency? Okay, F equals to V divided by lambda. So you just take 15 divided by 2.5. You get the answer is 6. 6 what? 6 hertz. Okay. Velocity of the wave is constant after reflection. True or false? Of course, here mentioned already, right? Tick one box. Okay, number 2. Okay, you try first. Give me the answer. Yeah, correct. Okay, OYG. Siapa OYG? Okay, try number 2. A ship uses ultrasonic wave to determine depth of the sea. Time interval between transmission of wave and receiving of the echo is 0.8 seconds. If the wave speed is 1,500, calculate the depth. Phenomenon of at the sea. Let's say this is a ship. Okay, there's a transmitter. This transmitter. Okay, transmit sound wave. Okay, transmit sound wave down. Below here is the seabed, dasar laut seabed. Ni ada banyak batu-batu dan sebagainya lah. Okay, this is the depth of the sea. Depth of the sea. Okay, let's say the transmitter transmit sound wave, ultrasound. Okay, hit the seabed, reflected. Hantu balik, reflected, received by the receiver. Okay, the speed of the sound wave that travel through the seawater is V. The time taken 0.8. Calculate depth. Time interval between transmission and receiving, meaning pergi balik. Dia tak boleh measure pergi saja atau balik saja, tak boleh. Because we don't know when it hit the seabed. Okay. Okay, anyone with the answer for this one? Number 2. 600 meter. Okay, 600 meter. Okay. Okay, let's check the answer. Okay, depth of the CG equals to VT divided by 2. The speed 1,500, time taken 0.8, divide by 2. Yes, good, correct. 600 meter. So this one is 600 meter. So this one normally come out in calculation problem. Paper 1 always come out this question. Okay, so using the formula. Okay, do you have any question regarding this one? Ada soalan? Fadlin? All right. So if no question, I still have about 15 minutes. Let's go to the next one. Okay. This one very fast. Ini macam speed up punya kelas. Okay, tak apa. Okay, second wave phenomenon, refraction. Okay, some of it you have studied in lower form. I think it shouldn't be a problem. You have previous knowledge on this. Refraction, definition. Change in direction of propagation of wave caused by change in velocity of wave when the wave propagates from one medium to another. Okay, maksudnya ada perubahan dalam direction dia. Why? Because change in speed or velocity. Speed also can. There is change in speed of wave when wave propagates from one medium to another. Same thing, we will discuss about three waves: water wave, sound wave, light wave. Different type of wave depends on the medium, depends on the what factor that affect the speed of wave. Okay, for water wave, the speed of wave depends on depth. For example, middle of the sea and the shore, different depth of water. Middle of the sea, water wave travel at higher speed. Okay, near to the shore at slower speed. This one logic lah. Kalau water wave, let's say kita ada macam ni. Let's say I have a cross section of a pond. Let's say we drop a stone here, middle of the pond. Cross section part only, ini pond. So you can see there are two sections. This one is deep region. This one is shallower region, shallow, air sikit. Okay, means the wave will be traveling here, will be traveling from deep. Okay. Salah lukis sekejap. Saya bikin nampak sikit. Okay. As we know, the water wave travel by vibrating a water molecule. For deep region, you can see more number of molecules to transfer the energy. Okay, compared to the shallow one. Okay, so energy will be transferred faster. When energy transferred faster, molecules, okay, will vibrate and produce wave higher speed. Okay. Saya nak tunjuk perbezaan. Tak nampak beza tak? Okay, sekejap. Bagi nampak beza sikit. Okay, ini higher speed. Higher speed. Sampai sini shallow, less molecules, slower. Amplitude decrease sebab memang ada energy loss lah. Kita sampai tu kan. Ini logik lah. Kalau sea ataupun mana-mana ada energy loss daripada middle of the sea to the shore, of course the amplitude will become smaller. Okay, from here you can see a distance between two crests is lambda. Lambda decrease, speed decrease. Okay, V equals to F lambda. The wave that travel from deep and to the shallow, they are coming from the same source here. Frequency of wave, remember, equals to frequency of source. Source tu yang menghasilkan wave tu. Apa yang hasilkan wave? The wave coming from the same source, meaning they have same frequency. Or we can say frequency constant. When frequency is constant, relationship between V and lambda is directly proportional. Deep sea, higher speed, longer wavelength. Shallow sea, okay, lower speed, shorter wavelength. Okay, itu ialah water wave. So water wave depends on depth of water. The higher the depth, the higher the speed. Okay, depth increase, V increase. Ini untuk water wave, water wave. Okay, when we talk about sound wave actually there are more than one factor. One of it is density. Density of air, temperature of air, okay, warm air or cold air, okay, ada effect pada speed. Lagi satu ialah dia punya state of matter. Sound wave travel faster in solid compared to liquid compared to gas because the molecules are closer. Because in the 5.1 we have discussed sound wave travel due to vibration of the molecule of particle. Molecule dia vibrate. Okay, kalau molecule dia very close like in solid, the vibration will occur faster. Okay, so energy transferred faster. That's the reason sound wave travel faster in solid compared to liquid compared to gas. Okay, untuk sound wave, ini saya tambah special sikit. Speed in solid is more than liquid, more than gas. Okay, gas memanglah sebab molekul dia sangat-sangat jauh kan. Jadi dia travel slower actually. Okay, temperature, the higher the temperature, the higher the speed. Okay, density, kalau denser, dia travel slower. Ini depends lah, kalau density ni saya tak boleh cerita juga di sini sebab dia ada dua bahagian juga. Density ada dua faktor untuk sound. Air, sama ada density is caused by arrangement of the molecules closer or due to the size of molecule which is bigger. Okay, dia ada dua. Okay, bahagian ni. Nanti kalau ada bahagian kita boleh discuss. For example, you compare between carbon dioxide and helium. Carbon dioxide is denser. Molecule is bigger, CO2. Okay, so it vibrates slower because heavy. So sound wave travel slower in carbon dioxide compared to hydrogen, for example. That one is in concept of density of air. Okay, light wave. Light wave just optical density. Glass, water, air. Okay, density increase, speed decrease. Light travel the highest in vacuum, followed by air. The slowest in higher density medium. Okay, jadi itu konsep yang ini saya explain secara ringkas, nanti kita akan lihat balik ya. Okay, let's look at this one, water wave. Deep, shallow. Speed in deep, faster. More number of molecules vibrate to transfer energy. So transfer faster. Shallow, slower. In deep region, wavelength longer. In shallow region, shorter. Okay, ini sebab B directly proportional to lambda. Speed increase, wavelength increase. Speed decrease, wavelength decrease. Okay, let's look at the sketch here. This is the arrow here. This is incident water wave. Incident. This is the wavefront. We have a line here that separates between deep and shallow region. Incident at this point. At this point, draw normal line. Okay, draw normal line. Angle between incident wave and normal line, angle of incidence. When travel from deep to shallow, speed decrease. When speed decrease, it causes the water wave to bend or refract towards normal. Okay, dia akan bergerak ke normal sebab dia slow. Okay, you draw this one direction. This is the wavefront for deep region, and then you draw for the refracted wave first. After that, you add in the wavefront 90 degrees to direction. Okay, let's look at the lambda. Okay, this is lambda in deep region, lambda 1. Lambda in shallow region, lambda 2. You can see from here, lambda 1 is longer than lambda 2. Why? Because speed in deep region is larger than speed in shallow region. Okay, so you must be able to sketch this one. Okay, let's move to the step to draw refracted wave. Okay, how to draw? You must use ruler and pencil to draw. Okay, let's say we have this one. Diagram shows water wave propagating from deep to shallow. This one is deep, ini shallow. Kenapa ini shallow? Kalau kita gunakan one water tank, this one we will discuss about ripple tank, water tank. Put some water inside. There is water inside. at certain depth. Okay, so if you don't put anything, they have a constant depth. To study refraction, you must create different depth region. So what we do, we put a perspex plate inside. Letak satu perspex di sini. Let's say 3 cm atau 5 cm. So means this one is deep. When you put a perspex above, the perspex is shallower than this one. Okay, so you created shallow region. Okay, so the shallow region follow the shape of the perspex. Sebab perspex tu shape ini, so kita dapat shape untuk shallow macam ni. Okay, sekarang kita nak draw. This is wavefront for incident wave. The first step is draw direction. Lukis direction dulu. Mana-mana point? Bawah sikit lah sebab nanti nak lukis senang. Okay, so ini ialah incident wave. Incident. Okay, at this point, draw normal line. Nampak tak garis ni? This is a boundary that separate deep and shallow. Garis ni. Okay, lukiskan normal line 90 degrees to the boundary. So ini ialah angle I. Okay, travel from deep to shallow, B decrease. Okay, speed decrease. When speed decrease, bend. Line lukis tu. Okay, bends towards normal. Kalau tak ada refraction, let's say I want to show you which part you nak draw bends towards. If no refraction, the water wave will travel in a straight line like this. It will continue to travel in straight line if no refraction. Bends towards normal, you draw in this region below this line. Ini maksudnya bends toward. Mana-mana tempat you boleh draw. If bends away, you kena draw above. Okay, kena draw above. Okay, so now I want to rub off this one. Just to show you the contour line saja. So means it will be refracted towards normal. Mana-mana point di mana angle yang lebih kecil. Angle R. Angle R is smaller than angle I. Smaller. Okay, you sudah dapat direction. Okay, now you want to draw the wavefront. Okay, draw the wavefront. Okay, cara draw wavefront, sambung saja dari atas sini. Let's say I add one more here. One more. Sambung dari atas ini. Then 90 degrees to the signal, to the direction here. 90 degrees. Guna ruler lah lebih cantik. Saya sebab freehand, so dia sengit sikit. Better use ruler. Okay, 90 degrees dengan direction. 90 degrees lah sini. 90 degrees. Okay, sengit juga. Yeah, I try my best to draw. Okay, this is the wavefront from here to here. Okay, and then the second one ni, you pun draw dia 90 degrees juga. Mesti 90 degrees juga. Okay, jadi you dapat dua dah. Okay, okay, you can see from here we can set dia punya wavelength. Wavelength ya. Okay, so dapat dua wavefront. Maksudnya new wavelength hanya saiz ini. So what happen next? You kena sambung ataupun add some more. Add some more tapi distance yang sama. Tambahlah beberapa lagi. Tambahlah beberapa di mana wavelength dia adalah same. Just make sure the wavefront that you draw here is 90 degrees to direction. So this one is the red color, represent the wavefront for refracted wave. Jangan guna freehand macam saya. Nampak tak line dia tak cantik? Kita nak dapat wavelength yang constant. Sama besar sini. Okay. So you can see ini lambda yang pertama. So when travel in shallower, lambda become shorter. Jadi automatically you akan dapat shorter. Bila you sambung to wavefront, automatic you akan dapat shorter. Okay, so teknik di sini bawah ada explain juga by you all. Okay, draw line represent direction dulu ini. Draw normal line. Wave propagates into shallow region, becomes slower. Refract closer to normal. Draw wavefront in shallow region 90 degrees to direction. Okay, nampak? Okay, line should be closer to each other as wavelength shorter. Mesti nampak perbezaan. Mesti nampak perbezaan. Okay, lambda 1, lambda 2. So ini teknik untuk drawing bagi refraction of water wave. Okay, refraction of water wave. When we discuss about sound wave, okay, ada soalan tak ni? Okay, ada soalan tak? Okay, okay now, tadi itu water wave, water wave reflect. Kalau sound wave macam mana? Refraction of sound wave. Okay, refraction of sound wave, speed of sound depends on many factors. Okay, when we discuss about during day and night, the factor is temperature. Temperature of air affects sound wave. Okay, let's look at here. During daytime. Why during daytime sound not clear to observer? Why nighttime is very clear? If you talk slow also, we can hear your voice. Something like that. So let's look at the definition, the explanation. During the daytime is hot day, let's see. Layers of air right above ground is warmer. Panas. Means layers of air near the ground is warm. Above is cold. Sound wave move faster in warm air. Okay, so move faster in warm air. So what cause? Sound refracted away from the ground. Okay, maksudnya kalau hari ni dia refract away from the ground, maksudnya dia akan lost to the atmosphere. Dia akan naik atas dan hilang. Okay, you just can hear maybe 50% of the sound coming to you. Okay. Sound refracted away from the ground, sound not clear to observer. Okay. During the night time, layers of air above the ground is cooler, lebih sejuk. Sound moves slower in cold air. Speed is smaller. Okay, when speed is smaller, sound refracted towards the ground. Okay. So sound clearer to observer. Refracted towards the ground and come back to you. It's like the sound is coming to you. It does not lost to the atmosphere above. That's why if the sound coming is 100% coming, then you can hear about 90% or 80%. That's why the sound is louder at night compared to daytime. Sound is heard louder at night. We need one phenomenon. Okay, refraction of sea wave. Okay, ini adalah beach. Beach ada bahagian cape and bay. Ini cape area, ini bay area. The cape is shallow region, while bay is deep region. Okay, at cape, wave is slower, so wavelength is shorter. At bay, wave is faster, so wavelength is longer. The difference in wavelength causes wavefront to curve and follow shape of the shoreline. Energy converge to cape, diverge from bay. So this one will cause amplitude of cape is bigger than bay. Can you see the difference or not? When we talk about wavelength, okay, because bay area is deeper, deep, so the wavelength is longer compared to cape area. But due to the shape of cape and bay, water wave when travel towards cape, it will be converge. Dia akan bend towards normal and converge to cape. When converge to cape means energy of wave will be all accumulated here, berkumpul di sini. So it become higher amplitude of wave. So this one is a bit wavy area. Short wavelength, but wavy area, high amplitude. Okay, when we talk about bay, because of the shape here, longer wavelength, but wave will be diverge because of the shape, bends towards normal and diverge at bay. When diverge, energy here is smaller. When energy is smaller, this one will become calmer sea. Lebih tenang, air lebih tenang sini bay area compared to cape area. That's why kalau you nak mandi laut, mandi dekat bay area, not cape area. Okay, even though you can see nampak macam it's deeper, tapi the wave is calmer. Okay, tapi untuk compare deeper at the beach, not so deep lah, not so deep. Okay, so ini juga ada soalan AC paper 2. Okay, maksudnya you need to choose which one is the best area to build a resort. Is it cape or bay? So we use bay. Okay, so explain all. Gunakan konsep inilah. Depth, wavelength, speed, okay, converge, diverge. Okay, untuk explain tu. Okay, solving problems involving refraction of wave. Okay, ini adalah deep region. Let's say ini water tank, kita letak satu glass block. So ini adalah shallow region. Wave speed V equals to F lambda. So F equals to V over lambda. Frequency is constant because the wave produced by the same source. Wave yang travel dari deep pergi shallow, shallow pergi deep ni sama, coming from the same source. That's why frequency constant. When frequency constant, V over F is constant. So V1 over lambda 1 equals V2 over lambda 2. So we can use this expression to solve problem calculation. Okay, example, the speed and wavelength in deep region given, speed in shallow region also given. So you can just denote this one. For example, the first one speed, you can in deep region V1 lambda 1, something like that. Okay, for shallow region is V2, you want to find lambda 2. Okay, so use this one. V1 over lambda 1 equals V2 over lambda 2. So you just ganti and then you get the answer. Check unit, check dia punya unit. Apa unit yang digunakan? So your answer is centimeter. 1 centimeter. Okay, this one, exercise 1. Diagram shows water wave in deeper region approaching shallow region. Deep, shallow. Complete the diagram by drawing. Extend your drawing to include wavefront after passes the shallow back to deep region. Jadi kita akan lukis bahagian ni. Okay, method. First step tadi, draw direction dulu. Wavefront 90 degrees to direction. At this point of incident, draw normal line. Means the incident wave is incident along normal line. So at this one, angle I equals angle R. Okay. Kalau dia along normal line macam ni, angle I equals to angle R actually equals to 0 degrees. There's no angle between incident wave and normal line. So R also 0 means the wave will continue to move in the same direction. Dia masih terus bergerak dalam direction yang sama. So ini special case. Kalau angle of incident 0, maksudnya incident along normal line, dia akan travel straight. Or you can just check like this. Direction and boundary. Ni boundary, boundary 90 degrees. If direction and boundary 90 degrees, dia akan travel straight. Okay, no refraction. Okay, no refraction. Sebab refraction ialah change in direction. Okay. Okay, now we want to draw the wavefront on shallow region. Because this one shallow region, so V dia kita tahu mesti smaller. Lambda mesti shorter. Even though no refraction, tapi speed and lambda still change. Okay, jadi hanya drawkan line closer saja. Mesti ada beza before and after. 90 degrees. Draw lah. Macam tu. Okay. Sekarang kita nak draw bahagian ni pula. Shallow pergi deep. Okay, ni nampak tak dia punya incident. Ini adalah dia punya reflected wave untuk shallow tadi. Okay, sampai sini lagi sekali ya. Shallow to deep. Draw normal line. Normal line 90 degrees to boundary macam ni. Okay. Shallow to deep, speed increase. Kalau speed increase, no, kalau tak ada refraction, dia akan continue straight. Kalau speed increase, bends away. Away maksudnya ke atas. Kalau bends towards, ke arah normal line. Bends away. Bends away like that. Okay, itu maksudnya bends away. Okay, sekarang you sudah lukiskan direction. Now we want to draw the wavefront. Macam mana draw wavefront? Ingat sambung dari atas. Dari atas sini. Sini semua kita akan buat sambungan. Okay, dari sini sambung. 90 degrees to this one. Jadi guna ruler 90 degrees. Okay, ini pun sambung. Parallel to the first one. Sambung je, parallel. Parallel dengan yang ni. Ini pun you sambung parallel. Okay, kalau ada lagi di atas, sambung. Atau just add some more. Automatic you akan dapat lambda sudah bertambah. Lambda tambah balik. Okay. Ini yang first one. Ini shallow, smaller, shorter. And then go back to deep, increase again. Okay, so ini adalah dia punya drawing. Okay, number 2. Ada berapa soalan lagi ya? Ada ini, okay, ada sikit lagi. Saya akan habiskan soalan ni. Okay, number 2. Your school recreation club plans a camping trip. One of your friends suggested that it is best to camp near a cave. As physics student, explain to your friend why it is safer to camp near B. Tadi saya dah explain kan? Okay, at B kita dah tahu tadi. Water waves diverge and produce smaller amplitude of wave. The wave the sea water at bay is calmer. Lebih tenang air dia, tak wavy. Calmer maksudnya safer to swim lah. Lebih tenang. Amplitude kecil, sikit je. Mungkin ada ripple sikit. Okay, water wave diverge and produce smaller amplitude of wave. Sea water at bay is calmer. Ini tengok berapa soalan, berapa markah Kalau 10 markah tak cukup kan ni Ikut markah dia. Okay, number 3 Deep region, shallow region. Okay, speed in deep region 2.5, calculate speed in shallow. So ini adalah between crest. Between crest ialah 1 lambda. Ingatlah yang kita dah belajar sebelum ni, ini 1 lambda. Okay, ini pun lambda, 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 lambda. Tapi ini lambda 2 lah. Sebab ini shallow kan. Ini lambda 1. Maksudnya dari diagram you dah boleh calculate lambda wavelength. Okay. Let's say deep region kita letak V1. So V1 is 2.5 cm second negative 1. What is lambda 1? Ini ada 2 lambda 5, maksudnya 5 divided by 2. 2.5 cm. Okay. Untuk shallow region dia nak you cari V2. Lambda 2 berapa? Ini ada 1, 2, 3, 4. 4 lambda. Maksudnya 5 divided by 4. Okay. (1.25) 1.25 cm. Okay, now use the formula V1 over lambda 1 equals V2 over lambda 2. Jadi hanya gantikan saja 2.5 divide 2.5 equals V2 over 1.25. Okay, so ini cancel 1, maksudnya V2 ialah 1.25 cm second negative 1. Okay, jadi dia lebih rendah kan, boleh check lah. Ataupun kita boleh lihat sini the wavelength become half. Nampak become half 2.5 become 1.25. When wavelength half, maksudnya speed also half. Sebab hubungan dia ialah directly proportional. Okay, frequency constant. Okay, number 4. Diagram shows sea water approaching land. Based on diagram, answer following question. Okay, soalan. For region X and Y, compare depth and speed. Ini nampak tak ini? Ini crest, ini crest. Maksudnya ini lambda. Ini crest, ini lambda. Kalau ini lambda longer, maksudnya dia deep region. Boleh nampak jelas pun deep kan. Ini shallow. Okay, yang ni speed higher, yang ni speed smaller. Okay, jadi you just write down macam mana comparison dia. Okay, depth of X, depth X more than depth Y. Okay, kalau speed, speed X more than speed Y. Saya guna simbol lah, you jangan guna simbol, you tulis penuh. Wavelength X longer than wavelength Y. Amplitude sama tinggi tak? Same. Okay. state relationship between depth and wavelength of wave. Okay, the higher the depth, the higher the wavelength. Ataupun when depth increase, wavelength increase. The higher the depth, the longer the wavelength. Itu relationship. Okay. The higher the depth, the higher the speed. Kita compare sini, nampak tak? Depth higher, speed higher, wavelength longer. Nampak? Okay? Depth dengan speed longer, higher. Okay, higher, higher. Depth dengan wavelength longer ataupun higher, higher. Sebab tu kita dapat relationship macam ni. Okay? Itu based on comparison. Ini soalan structured, biasa soalan compare ni ialah soalan 5 ada 6. Tu boleh tahu cara compare. Ini analisis. Soalan C ya. Speed and wavelength region Y given. Untuk Y punya, ini lambda Y. Calculate wavelength Y if wave speed Y. Apa ni? Not Y lah, should be another region. Just put X. Dia dah pergi different depth lah kan, maksudnya. Let's say ini ialah lambda X. You want to find Dx. So the same thing, V1 over lambda 1, V2 over lambda 2. Just ganti, okay? Dia dapat berapa? Okay, okay. Smaller speed lah, shallow region. Okay, so now it's near 10:30. Okay, for those in my class, please go and do again all exercise that I have discussed now. Okay, if you think that you cannot catch up now, you can watch later and pause the video if you want to check the answer. Okay, do you have any questions before I end class? Okay, Tan Jin Chia, thank you. You get 7.5 correct. Okay. So it's a very long topic tonight. I have covered topic 5.2, 5.3, and 5.4. Okay. So I will carry out experiment in the lab on this. So 2 phenomenon already done. Okay. Go and read textbook. Okay. Better for explanation. Okay. If you have any question, you just write in the chat. I have another 3 minutes. You want to answer to ask any question, starting from the topic of damping and resonance. Okay. If we want to summarize the whole topic tonight, so what is damping? Okay, decrease in amplitude with time due to energy loss. Okay, energy loss due to external damping, internal damping. And then resonance, when force frequency equals to natural frequency, the system oscillate at the maximum amplitude. Itu resonance. And then we discuss about reflection. Reflection is wave bounces back when hits a reflector or obstacle. Okay, and then application of reflection. So widely used is ultrasonic wave, sound wave. Untuk reflection, you boleh baca lagi. There's a calculation problem using the formula D equals to VT divided by T. And then we discuss about refraction. For refraction and reflection, you must know how to sketch diagram. Reflected wave pattern, refracted wave pattern, kena tahu lukisan. Soalan structured. Boleh panggil you all lukis. Okay. And then ada calculation problem using the formula V P1 over lambda 1 and V2 over lambda 2. Okay, if you don't have any question then I think I will end class now. Okay, thank you for joining me tonight. For those from my class, please register your attendance using the Google form. Okay, so thank you for joining me. Bye. Good night, everyone.